right, this one, okay, this one has to do with right triangles. Okay, you won't have one this comprehensive on your test, but again, it's good for you. I just wanted you to have some experience with these, okay? So we're given that angle A and C are right triangles, and we're told that AB is congruent to CD. And we want to prove that ABD, so this triangle here, is congruent to the other triangle, CDB. Okay. Now, if you remember, the first statement is always the given information. Okay. A and C are right triangles, and we're told that AB is congruent to CD. Now, ABD and CDB are right triangles. Well, why is any triangle a right triangle? Because that's the definition of a right triangle. It has two right angles. And we are told that by this here. Okay, so B is number 2. It's the definition of a right triangle. Definition of a right triangle is a triangle with a right angle. And we're given that. Now, here, they flip-flopped DB and BD. They're the same thing. They did it for just to indicate that the same side is shared by two separate triangles. Okay, and we know, as I've mentioned earlier, that any shared side can be considered congruent. And you may or may not remember, but that is the reflexive property. The reflexive property, it says that anything is congruent to itself. So that's going to be C. So now if you take a look at this, what are we given? We have a right angle. We have technically one side of a right angle, which we call a leg. And BD for both triangles is the hypotenuse. Okay, so this is the one right triangle congruence theorem that some of you may or may not remember from class last time. We abbreviated HL, hypotenuse leg. Okay, so that is going to be 4 is going to be F, hypotenuse leg. And that's the only right triangle congruence theorem you need to know. All right. Number 13, again, I would draw a picture, because without it, I can't visualize it myself. So we've got PQR. We're told that PQ is equal to QR. Okay, so those are congruent. Angle P, so that's here, 3x minus 120, sorry, R, x minus 30. Classify the triangle PQR. Okay, well, just by looking at this, because PQ is congruent to QR, by definition, this is an isosceles triangle. Okay. To determine what other type of triangle it is, we need to solve for x to determine the angle measures. Now remember, that in an isosceles triangle, the base angles across from the congruent legs are also congruent. So I can set up my equation so each of the algebraic expression is equal to one another. So I'm going to add 120 to both sides. I believe in my mental math, minus x, so I get 2x equals 90. So when I divide by 2, x equals 45. Okay, so if that's the case, so x is 45. So, but don't make the mistake into thinking that's the angle measure. Okay. I have to plug 45 in for x, making angle R 45 minus 30, so that's 15 degrees. Now, both angles are congruent, P and R, so this is also 15 degrees. Okay, which means angle Q is obtuse. So when categorizing this triangle, it's isosceles, but it is also obtuse, because the obtuse angle to have an acute triangle, you would have three angles that were all less than 90 degrees. But here you have two acute angles and one obtuse angle. So the obtuse angle trumps the acute angle. And that is it. Those are all your questions for your practice test.